Hello and welcome back to Saxon Math. This is lesson 31, expanded notation, and more on elapsed time. Apparently it's a new concept. Let's dive right in. The price of a new car is $27,000. The price of a house is $270,000. Which price is more? Or are the prices the same? How do you know? Recall that in our number system, the location of a digit in a number has a value called its place value. Consider the value of the 2 in these two numbers. 27,000 and 270,000. So when you're looking at the 2 in those two numbers, in 27,000, the value of the 2 is 2 times 10,000. It's in the 10,000s place. In the 270,000, the value of the 2 is in 2 times 100,000. Therefore, 270,000 is greater than 27,000. To find a digit's value within a number, we multiply the digit by the value of the place occupied by the digit. To write a number in expanded notation, which is today's lesson, we write each non-zero digit times its place value. So for example, that 2 is in the 10,000s place, and in this case, the 2 is in the 100,000s place. So this one is in the 10,000s place, and this one is in the 100,000s place. So all you do is take that digit 2 and multiply it by its place value. The place value is the 10,000s place. So you multiply by 10,000. This one, this digit 2, is in the 100,000s place. So we multiply it by 100,000 to expand the notation. As it is right here, this is considered standard notation. This would be standard notation. This would be expanded notation. Standard notation, expanded notation. Later this year, we'll be doing expanded notation with exponents, but as it is right now, we're just multiplying by the place value. Let's look at an example. So write 27,000 in expanded notation. The 2 is in the 10,000s place, and the 7 is in the thousands place. So to write it in expanded notation, you simply have to do 2 times 10,000 plus 7 times 1,000. Since 0 times any number equals 0, it is not necessary to include zeros when writing numbers in expanded notation. So the 2 times 10,000 is actually like 20,000. And the 7 times 1,000 is the same as 7,000. If you were to add those two together, you would end up with 27,000. This is the standard notation. Expanded notation is 2 times 10,000 plus 7 times 1,000. That's expanded notation for the standard notation of 27,000. If it happened to be something like, if it was 27,080, here's what this would be. It would be 2, the 2 times what place is it in? It's in the 10,000s place. So it'd be 2 times 10,000 plus 7. And where's the 7? It's in the thousands place. So we multiply it times 1,000 plus 0 is in the hundreds place, but we do not need to represent that because 0 times 100 equals 0. So we're going to move on to the 8. The 8 in this place value is in the tens place. So we multiply it times 10. And then we don't need to represent this 0 because 0 times 1 is 0 anyway. So the expanded notation of 27,080 is 2 times 10,000 plus 7 times 1,000 plus 8 times 10. Let's look at another example. Write 5 times 1,000 plus 2 times 100 plus 8 times 10 in standard notation. Very simply put, this is 5,000 plus 200 plus 80. You may already know that answer to be 5,280. So standard notation is just your usual way of writing numbers. One way to think about the number is 5,000 plus 200 plus 80. Another way to think about this number is 5 in the thousands place, 2 in the hundreds place, and 8 in the tens place, and then you have to assume a 0 in the ones place because it has to have that placeholder. So it'd be 5,280. How would the expanded notation change if we added 20 to 5,280? Well, if you added 20 to that, that would change this to 5,300, and that in expanded notation would simply be 5 times 1,000 is the 5,000. It'd be 3 times 100 is the 300, and there would be nothing for the two zeros there because 0 times 10 is 0, and 0 times 1 is 0. So this would be the expanded notation. So if you need to double check your expanded notation, just do the math. 5,000 plus 300. Well, if it equals 5,300, you're on the right track. Example 3. Before we do that, I guess we need to look at a little bit about elapsed time. The hours of the day are divided into two parts, AM and PM. The 12 a.m. hours extend from midnight, 12 a.m. to the moment just before noon, 12 p.m. The 12 p.m. hours extend from noon to the moment just before midnight. Recall from lesson 13 that when we calculate the amount of time between two events, we are calculating elapsed time, the amount of time that has passed. We can use the earlier difference pattern to solve elapsed time problems about hours and minutes. So for example 3, Jason started the marathon at 7:15 a.m. He finished the race at 11:10 a.m. How long did it take Jason to run the marathon? So the problem has a subtraction pattern in this case. We can find Jason's race time, which is elapsed time, by subtracting the earlier time from the later time. So the later time is 11:10 a.m. and the earlier time is 7:15 a.m. So in order to subtract, find the difference of that, since you cannot subtract 15 from 10, we need to rename our 1 hour from the 11 o'clock to take 60 minutes from it. Those 60 minutes plus 10 minutes will make it 70 minutes. This means that 70 minutes after 9, which is the same as 10:10. So in this case, we want to subtract, we're borrowing 1 hour, turning it into 10, and we're adding that 1 hour onto the minutes side. If we throw in 1 hour over here, it's 60 minutes. This is hours, this is minutes, remember. So that makes 10 plus 60, 70. Now you can take 70 minus 15, and when you do that, you get 55. And then you just take the hours, they have to be separate. So it'd be 3 hours and 55 minutes is the distance, the duration it took Jason to run the marathon. What time is 2.5 hours after 10:43 a.m.? Now keep in mind you might be crossing over the PM mark on this. So it starts over at 12, you're counting, you're not going to go up to 13 unless you're using military time. This is an elapsed time problem and it has a subtraction pattern. The elapsed time, 2.5 hours, is the difference, and we write the elapsed time as 2 hours and 30 minutes because 30 minutes is half of an hour. Remember, the full hour has 60 minutes. The earlier time is 10:43 a.m. So if it's 10:43 a.m. and you add 2 hours and 30 minutes, he'll describe, there's two methods you can do it, mental calculation and pencil paper calculation. For the mental calculation, we'd first count 2 hours after 10:43 a.m. 1 hour later is 11:43, another hour later is 12:43 p.m. Note the switch from a.m. to p.m. From 12:43 p.m. we can count 30 minutes, which is a half hour. To do this, we can count 10 minutes at a time from 10:43 to 12:53 to 1:03 to 1:13 p.m. and we find that 2.5 hours after 2:43 a.m. is going to be 1:13 p.m. If you're going to do pencil and paper calculation, it would look like this. Notice that the time switches from a.m. to p.m. and that the sum is 12 hours and 73 minutes. p.m. is improper. If you were to add those together, you'd get 73 for the minute side and 12 for the hour side, and that would change from a.m. to p.m. Since we think of 73 minutes as 1 hour plus 13 minutes, we can add 1 to the hours and write 13 as the number of minutes, so that 2.5 hours after 10:43 a.m. is 1:13 p.m. So it would be adding 1 hour to that, and then this is the same as 13 plus 60, so 73 minutes. If you were to subtract the 60 minutes out of it, you would be left with 13 minutes. And then if you were to add that into the hour side, 12 plus 1, in p.m., it's not going to be 13 p.m. Remember, it's going to now be 1. It's be 1:13. So remember, it's 12 p.m. plus 1 hour after that would make it 1:13 p.m. All right, let's try these here. So write each of these numbers in expanded notation. So the first one, all you have to do is start your parentheses. You have 2 times what place value is the 2 in that you would multiply it by. It should be the 100,000s place. So you would simply write 2 times 100,000 plus 7 times what place value that's in, the 10,000s place, and that is your expanded notation. Letter B, go ahead and do that one. So you'd take 1 times 1,000 plus 7 times 100 plus 6 times 10. Just make sure those are in parentheses. There's the expanded notation of that one. All right, and letter C, 8,050. 8 times 1,000 plus 5 times 10. Letter D, write each of these numbers in standard form. So in this case, you're just taking this expanded notation and writing the standard form of the number. If you don't remember what that is, it's just going to be the 6 times 1,000 plus 4 times 100. And whatever you get for the answer to those your problems there. So 6,000 plus 400 is simply 6,400. Letter E, 7 times 100 plus 5 times 1. You should have 705. Why is it 705? Because this is just 5 and this is 700. Add those together. Let's try some elapsed time problems. So letter F, George started the marathon at 7:15 a.m. and he finished the race at 11:05 a.m. How long did it take George to run the marathon? And how do you know your answer is correct? We'll go ahead and do letter F. So as I work through this, I would start with the later time, which is 11:05 a.m. And I can see that they're both a.m., so I can work with that. And I have 7:15 a.m. as well. I'm going to subtract that. I can take that 0, but I have to actually borrow. This isn't going to work. If I was to do that, I need to borrow from this. I need to borrow 1 hour from this, so it turns to 10, and this would be 65 on this side. So it'd be 1065 would be the equivalent when borrowing. So now I take that away. I've got 5 minus 5 is 0. 6 minus 1 is 5. And then I have 10 minus 7 would be 3. So it's 3 hours and 50 minutes. This is not an AM or PM answer. This would simply be 3 hours and 50 minutes for the answer. Letter G, what time is 3.5 hours after 11:50 p.m.? Go ahead and answer that one. All right, if I was going to add, if I started at 11:50 p.m., notice I'm really close to the threshold between switching from p.m. to a.m. It's close to midnight. 3.5 hours is the same as 3 hours and 30 minutes. If I was going to add those doing this, I would have 80 here, and this would end up being, well, if I go from 11, 12, and I know I'm going to be at 1. So I'm going to end up being at 1 a.m. and 80 minutes. So this is going to be labeled an AM because I crossed over the threshold. But now I need to recognize that this is 80 minus 60. That'd be the same as at least 1 whole hour added to that. So it's going to be 2 a.m. And then whatever is remaining of this will be my minutes. It'll be 2:20 a.m. for that one. Letter H, Dakota got home from soccer practice 4.5 hours before she went to sleep. If she went to sleep at 10 p.m., what time did she get home? Go ahead and attempt that. All right, so 10 p.m., if I'm going to subtract my time from that, that's 4 hours and 30 minutes, and I'm going to subtract that. I need to borrow from here. This is going to be 9 hours. This is going to be 60 here. 60 minus 30 would make 30. 9 minus 4 would be 5. So that'd be 5:30 p.m. would have been the time that she got home. If she got home from soccer practice 4.5 hours before she went to sleep, that's when she got home, and then she went to sleep at 10. All right, thanks for watching. If you missed any of these problems when practicing them, go back and review the video to see if you can learn something. Have a great night.